We present the VRoxy system, designed to enable remote collaboration in large space, allowing the user to navigate a large environment from a much smaller space using an automatic robotic proxy. VRoxy can facilitate multiple interaction modalities in space, rendering the user's body movement, pointing gesture, and head animations through the proxy. Mapping a VR user's movement to control a robot in a large environment can be challenging because the VR user space can be much smaller. To compress the wide space to the smaller space in VR, we designed a navigation interface where a VR user can see a 3D scan model to quickly understand the environment. The VR user can take a step onto the teleport link on the ground, which takes the user to another location after a fade to black transition, allowing the user to navigate this large space. To help the user understand where their collaborators are while navigating the space, VRoxy renders the presence of remote collaborators through an avatar using Connect tracking. As the VR user navigates the space, the mobile robot automatically reproduces the movement. Using these techniques, VRoxy allows the VR user to be at a certain location in the VR user's physical space for a corresponding task area in the remote space. As soon as the robot arrives at the same location, VRoxy enables the immersive live view to initiate interactions with their collaborators. To support micromobility, the VR user can move along the shelf in the live view, allowing the user to take a closer look at other parts of the area from a new position. VRoxy also supports multiple modalities of social interactions, rendering the non-verbal cues captured by Quest Pro on the proxy. The VR user's head rotation is mapped through the articulated display. Facial expressions and gaze direction are also rendered on the articulated display through an avatar created with Avatar SDK. For enabling pointing gestures to visualize where the user is referring to, VRoxy uses hand tracking to detect a pointing position inside the live view and renders it through a pointing arm. Here is the demonstration of typical interactions using VRoxy in a wide environment. The VR user first moves from the hallway to the lab space, understanding their collaborator's position in the shared space. This movement is reproduced through the mobile robot on the other side. Once the robot arrives, the VR user sees a live view and can point at a specific part for discussion. The user can move to the left to see a different part of the shelf for having discussion on another topic. Once they are done with the task at the shelf, the user can now move to the monitor to review a design. The VR user can see real-time updates of the shared screen, allowing the user to observe the task space as the robot approaches the monitor. Likewise, they can now move to a table to conduct another task. After the VR user completes a task with the collaborator in the lab space, the user can exit the room to the hallway. And enter an office where another collaborator is working. The VR user can see the shared screen and task camera, while the robot is replicating the movement. The VR user can start interactions with another collaborator and review the breadboard. With the help of non-verbal cues rendered through the robot, they can quickly switch their attention to the monitor. Once the VR user finishes the session, the user can exit the room to the hallway. The robot follows the user to exit the room. Using VRoxy, the user can instantly travel from one building to another building. Once the user enters another building, the mobile robot exits to the hallway to start parking to indicate that the user is no longer in the building. As the VR user sits on a chair, the proxy in another building reflects the notion of re-embodiment. As the user leans over the breadboard to have a close look, the robot can also lean over the breadboard. As the user looks at their collaborator for discussion, the robot can also look at the collaborator for discussion. After the discussion, the VR user can leave the table, which is reflected through the robot in the office. We presented VRoxy, a system that allows a remote user to navigate and collaborate in wide areas from a small space.